Recording in progress. Right. Topic for today is distributed storage system. Okay. We are talking about cloud infrastructure. When we talk about cloud infrastructure, we know many of its features. One of them is on the storage part. Okay. Can you guys imagine you have a lot of things that you want to keep in the cloud, right? You are storing your work or anything, your photos, yeah, in the cloud. So how does this system of storage works in the cloud, kan? So for this class, you should be able to understand. We are not going to develop the storage system, but you are going to know how does it function. Okay, so that's the topic for today. We are talking about distributed storage system. Why distributed? This is the most important, the most popular one in cloud for the storage system. All right. So as usual, I want to remind you all of you on the learning outcome. You should be able to identify the purpose and value of the cloud platform products and services. You also should be able to solve problem concerning the data and network security. This is from the disaster or cloud management. And you should be able to demonstrate some digital skills, application, deployment environment on cloud platform. So for today, we are going to look at how data are being stored in the cloud. Okay. So there are many methods or many approach to store data in cloud. And you must remember that we are talking about how the organization who provide the cloud for users. All right. So we are all the users. We have a lot of data that we can keep in the cloud. So we are the user, but we also want to know how the the owner of the cloud platform store their system, store our file into their system. Okay, so again, I mentioned just now many types, but for this topic, they are most similar. We are going to look at two types. Yeah? All right, I see several large. Yeah? We are going to look at the EC2 type, and also another one bawah sini, we call it a big data, big table. This is one. Another one that we're going to look at later today is called the GFS, okay, Google File System. So these are the two types of storage system, distributed storage system that you are going to learn, and many other types. Okay, yang kat sini ni, many other types, they work similar to these two. Okay, so I hope you understand when we talk about ini storage, you should be able to understand. And if people ask you, um, Desmond, how does storage happen lah in the cloud? Desmond nanti boleh jawab lah nanti. Okay, sorry Desmond, I'm just calling out because your name ada kat my screen. Okay, so you should be able to explain to other people how the storage are being set up or being used by the user. Okay, and how the organization who look after the platform do this. All right. In this class, we are not going to learn how to create the storage system. You are just going to know the existing one and how they function. Clear? Okay. Kalau you want to develop one, there will be some programming and so on, and that is not the scope of our topic. Right. Coming back to our example here. As I mentioned, many types of companies who provide a cloud platform. They also have many features in the cloud platform, including storage. Okay, so for today, kita nak belajar macam mana dia gunakan storage tadi. How do they create storage for us to use? Alright, so one type is called the big table. Okay, it is a storage system for structured data. Okay, you all must have learned or maybe heard of big data. Big data consists of structured data and unstructured data. Okay, those of you who do not understand, you can look up on the internet, yeah, structured data and unstructured data. Okay, but for our concern today is just to look at how storage for cloud platform. Yeah, so one is called the big table. What is it? It is a distributed storage for structured data designed to scale big. Okay, it is a big scale lah. Okay, petabytes of data and thousands of machines. Machines ini CPU lah, ya, or servers. Okay, so just imagine around the world there are billions of people. And remember in our classes before, we learned that cloud is focused on zones. Kan? Dalam dunia ni, they covered a certain zone. So zone Asia, for example, kan? So many peoples in Asia. Okay, so they have their platform for the Asian zone. And then we have the zone for the European and so on. Yeah? So, and all the company who provide platforms will follow the regulation or the policy in that particular zone. Okay, zone Asia, the regulation is a bit different from zone in the Europes. Yeah, and in one zone there are so many users. We are one of the users lah in Asia. So most probably our data are being kept in a big table type of storage. Okay, we do not know. Okay, that depends on the platform provider. Eh? Okay, coming back to big table, macam mana? How does it function? Okay, well, big table usually used by Google product. Google Earth, Google Analytics, web indexing, semua ni menggunakan big table. Alright, it handles diverse workload. Clients can control locality and whether to serve their data from memory or from disk. They can do that. Alright, so this is what big table under Google product. Okay, one method ataupun one type of storage system in the cloud. Okay, so how does it function? Okay, they use the word tablets. So dekat sini you must be aware that this tablet is not the same as the tablet that we have lah. Okay, just nama the tablet. It is basically a storage or a space which they define the name as tablets. So this tablet is not the same as the tablet that we use to go around macam handphone tu. Macam laptop. Okay, so tablets, let's understand it a little bit on the tablets. Okay, data is maintained in lexicographics order by row. Apa dia lexicographics order? I have a video on that later. Okay, basically it is used for structured data. Kan? If structured data, the pattern are very well suited by rows and column. Okay, mostly rows. So they are not scattered around. Okay, so this table use that features. So the row range of table can be dynamically partitioned. Each range is called a tablet. Okay, the unit of the distribution. Okay, so the tablet is actually the distribution, the unit of the distribution. Right. Another point is nearby rows will be served by the same server. So they are called neighborings. So good locality properties by properly selecting the rows will define the neighborhood of the rows in the tablet. Okay. Right. So how does the building block looks like? All right. The building blocks, okay, they have something that is called the Google file system. They store logs and data files because this is being used by Google, kan? So a big table cluster runs on a shared pool of machines, right? It depends on the cluster management system for scheduling. All right. The system SSD table file format is used to store big table data. So all of this are going to be explained by the help of a video. Last time it's difficult to explain this in class, but nowadays with YouTube and so on, I will show you a short video on all of these texts. Okay, but I just wanted to explain the text to you first. Yeah. Okay, so sambung balik. Important part kat sini ya, Google Access Table. Okay, so dia ada SS table for big table data. This is the size, and the big table kat sini, okay, uses the something that is called the chubby persistent distributed. Okay? It ensures that there is almost one active master at any time. Ingat tak, server kita ada master and slave, kan? So you need to have the master to be able to understand where the data are being put. Where dekat sini refer to tablets ataupun rows tadi. Okay, clear ya? So they have the um, uh, big table. Inside there are a lot of tablets. Tablets tu apa? Areas to store data. Okay, and it is put in a very systematic pattern. Okay, so that's the building block. Or how does it works? The implementation. Three important components. One is the library. Okay, the other one is the master server, and the third one is the tablets, and we call it the multiple tablets because tablets ni banyak, so many, petabytes. So master server assigns tablet to table servers, add and monitors table servers, balances tablet servers, load, and so on. Okay, so master will look after that. Macam yang saya cakap tadi lah. Okay, it will make sure that the storage are being put into a proper way. Okay, each tablet server, they manages a set of tables. They handles read or write on the data in the table, and they can be split into large or small tablets. Kan? Sebab dia punya partition of the tablet can be changed. Partition meaning you can have, imagine a parking lot, the size of the parking lot untuk kereta kita kan. The size of the parking lot, kalau parking kita tak boleh besar-besarkan lagi ya, we cannot change the size. But for this one, they can change the size. The border, okay, can be changed. Okay, become bigger or smaller. Alright. So itu computer lain. But just imagine a lot of parking space, parking lot that can be changed. The border can be changed. The size of the border can be changed to become bigger or atau small. Right. So that's big table and how they works. The when you talk about big table, the word tablets must be there. Okay, because that's how it functions. All right. So then you can explain to people tablets are defined as something for storage. Okay. Right. So that is called a big table. Yeah. And this is the simple diagram lah. Okay. For the big table. All right. We have, I want to start from here. We have this user tablet. Okay. Ini yang banyak ni user tablet dekat sini. Okay. They actually accept metadata from tablets before them. Okay, so just imagine user table 1, user table 2, user table 3. a lot of ini sangat besar ya, dia bukan 1 2 3 saja, millions, okay? And they receive metadata from other tablets, okay? And imagine these other tablets pun have something like this, all right? Okay, so can you try to imagine it? All of this sebenarnya ada dekat sini, metadata punya, and all of these are collecting data from the root table. They call it they give the name root table. Okay, so this root table obtain files from what they call the chubby file. Okay, um, the files here are in structured data types. Okay, so tengah hari ni, I don't know, you can try to imagine in this meta table, okay, tablet, there are a lot of user tablet dalam ni. Okay, so it's very very big. Okay, and all of this comes from root table. Root table ni tak banyak lah. Well, tak banyak macam tablet yang di user ni. Okay, and they come from the root table, and then the root table come from a structured data in the file which they call the chubby file. Okay, senang aja. Okay, so the address for this tablet, see, 2 to the power of 34. Okay, this is just for one example. Besar ni, the size is very big. The number is very big. And table assignment. Okay, this is not your assignment. This is the table. They assign the table. Okay, table assignment is they assign the table. Each tablet is assigned to one tablet server at a time. Okay. Master keeps track of live tablet server or any other assignment, current assignment, and unassigned tablets. Okay, so the tablet have one assigned tablet, one assigned data that they need to store. Okay, and bear in mind that data is very big. Bukan just one, for example, photo. Not just for one picture only. Okay, there could be a lot of pictures. In one assigned table. Okay, so master keep the track of the live tablet. Live tablet is the tablet that have something they store in. Okay, and upon master starting, it requires master to log in the chubby file tadi so that they are connected. Okay, they scan the live tablet, they get the list of tablets, and they learn set of existing tablets. Bear in mind, students, all of these are being programmed. Okay, they are not just something that can happen like that. Programming, you can develop this, okay, but you need to do the programming part. Okay, but this does not cover in our topic. So again, in terms of diagram, it's easier to see, okay, how they work. So we have the memory table, mem table, the memory table. So on top here is the memory, and this one is the Google file system. All right, so the memory table will go through the read operation, and these are all from the SS table just now. All right, and tablet lah dekat sini, and the Google file system tadi, they can give input to the memory table. Okay, so more details on this topic, but I want to share with you the video so that you can understand what I'm talking about this afternoon. All right, so semuanya in text. Okay, many years ago we teach this also in text. Nowadays ada video, very helpful. So let me share this video with you. Have a look. This is for the topic of big table. Okay, I switch off my screen first supaya this YouTube can play. Okay, let's try to run this video.
Grammarly now uses AI to help you write, not just revise. Type a prompt to generate a persuasive mistake.
Are you building an application that needs low latency and high throughput?
then you will need a database that can scale for a large number of reads and writes. Cloud Bigtable is designed to handle just that. Hi, I'm Priyanka Vergadia, and this is GCP Sketchnote, where I pick a Google Cloud concept and give you a quick overview. In this video, let's look at Cloud Bigtable, a fully managed white-column NoSQL database that scales to petabytes of data. It's optimized for low latency, large number of reads and writes, and maintaining performance at scale. It offers a really low latency of the orders of single milliseconds, and it is an ideal data store for time series and MapReduce style operations. Now, Bigtable supports the open source HBase API standard to easily integrate with the Apache ecosystem, including HBase, Beam, Hadoop, and Spark. It also integrates with Google Cloud ecosystem, including Memory Store, BigQuery, Dataproc, Dataflow, and more. Data is by default encrypted with Google managed encryption keys, but for specific compliance and regulatory requirements, if customers need to manage their own keys, then customer managed encryption keys are also supported. Bigtable Backups lets you save a copy of the table schema and data and then restore from the backup to a new table at a later time. How does it offer scale and high availability? Well, let's see. Bigtable delivers a highly predictable performance that is linearly scalable, and the throughput can be adjusted by adding and removing nodes. Each node provides up to 10,000 queries per second for reads and writes, and you can use Bigtable as a storage engine for large-scale low-latency applications as well as throughput-intensive data processing and analysis. And it offers a high availability with SLAs of 99.5% for solo instances. It is also strongly consistent in a single cluster. Replication adds eventual consistency across two clusters and increases the SLAs to 99.99%. So if that's your need, then go for a replicated cluster. Now, replication for Cloud Bigtable enables you to increase the availability and durability of your data by copying it across multiple regions or multiple zones within the same region. So how does Bigtable optimize throughput? Let's see. It does that through separation of processing and storage. So Cloud Bigtable is able to automatically configure throughput by adjusting the association of nodes and data. In the rebalancing example here, if node A is experiencing a heavy load, then the routing layer can move some of the traffic to a less heavily loaded node, improving the overall performance. The resizing comes into play when a node is added to again ensure a balanced load across nodes. This ensures the best overall throughput. Choice of app profile and traffic routing can also affect performance. An app profile with multi-cluster routing automatically routes requests to the closest cluster in an instance from the perspective of the application, and the writes are then replicated to other clusters in the instance. This automatic choice for the shortest distance results in the lowest possible latency. Now, for all the reasons I mentioned earlier, Bigtable is used for large-scale, real-time workloads in financial tech, ad tech, gaming, IoT, machine learning, AI personalizations, and more. Now, here's an example of real-time bidding platform where hundreds of thousands of click-throughs are ingested in Google Cloud using PubSub messaging service. Then they're processed in Dataflow and stored in Cloud Bigtable. In parallel, this data is sometimes also stored in cloud storage, which acts as a data lake, or BigQuery, which acts as data warehousing and analysis solution. There you have it, Cloud Bigtable, a fully managed, NoSQL, white-column database for real-time, low-latency, and high-throughput transactions. For more information, I have included the link to the documentation below. If you like this video, give it a like and subscribe to my channel for more cloud content.
Okay, so that is one example. There are a few more which you can have a look in YouTube, yeah. But anyway, that is the part which are very straightforward, okay, in terms of how cloud stores your data. All right. So again, you must understand that we are not developing the storage. We are just trying to understand how they function. Okay, we must understand how they function, and if you are involved in cloud computing, people can ask you how do they store storage in the cloud. You can explain. All right. So that is one. Okay. We continue for the second example. Okay, the first one is a big table. The second one that you need to know is the Google file system. Now, this one is actually also being used by Bigtable. All right. So Google file system was developed in the late 1990s. It uses thousands of storage system. Okay, so actually GFS was created first, but they have some slacks, okay, and they improve it by Bigtable. So GFS is being used by Bigtable, and Bigtable is much more reliable. Okay, motivation. So the GFS, they have this component failure usually happen. So that's the problem. Yeah, they have problems in a lot of errors when they try to run this. Yeah. Okay. Again, this is in the 90s, 1990s. Yeah? And they cannot also cater for huge files. Yeah? Tak boleh. Yeah? The most common operation is to append an existing file. They can adjust. Okay. Random write operation. But when they do the adjustment, some of the data seems to be lost. The consistency model should be relaxed to simplify the system implementation, but without placing an additional burden on the application developer. So they realize this, some data are lost, and these are some of the problems for the GFS. But when they improve it using the big table, better. Okay, so GFS have some assumption. The system is built from inexpensive commodity components. The system stores a modest number of large files. The workload consists of mostly two kinds of reads. Yeah? The large streaming read and the small random reads. Okay? They do not be able to have the write at that particular time. Tapi later in that years, they improve the GFS to be able to write as well. Okay? So these are the assumptions lah for the GFS. Okay, and of course GFS, they have the API. It provides a familiar interface through POSIX, support, create, delete, semua ada. So they have this function because they are under Google, so most of them are like this. Okay, they also have the three directory, kan? So these are all under Google feature. So this is the thing which I think you should be able to understand properly, the architecture of the GFS. So in this diagram, the GFS are going to be applied to many files that need to be stored by clients or user. Okay, so if you look at the legend dekat sini, data messages, the thick arrow, and the small arrow is the control messages. Okay, so all messages usually begin where everything works. Okay, nampak tak? The tablet they have not found the names yet. Okay, so everything happens here. The file names goes into the chunk, and then everything will communicate back to the GFS chunk server. Okay, so this comes and can store. And bear in mind, this one yang banyak-banyak ni actually ada dot-dot ni kan. This is actually showing that this GFS chunk server has many. Okay, the number is a lot. All right. So each GFS server will have the server down here, and there are so many of them dekat sini. Okay. So just imagine all the storage are being kept using this style of GFS. Okay. So the cluster, single master, multiple chunker server and clients, and running on Linux machine. Okay, they have the fixed size chunk of 64-bit. The chunk are stored on local disk or what they call the chunk server. And the master maintain all the file system in metadata. And the client of GFS could implement the API, and caching of the client on the chunker server are being the caching by the client or the chunk server yang ini. Okay, and they have a lot of this chunk server. All right, so this is basically the GFS. So the big table is an improvement of the GFS, and nowadays there are a lot of storage methods or techniques in the cloud. Yeah, so these are the um, very old one that started the storage part. Okay, so the design and decision of GFS you can read on this, but these are the two things that you understand, and most of the storage style nowadays uses the same techniques. Okay, I have another video for you on this GFS. Let me see GFS. What is GFS? Here we are. Okay, so let's have a look at this one now. What is GFS to make sure you have the rough idea lah.
What is the GFS model? Have you ever wondered how meteorologists predict the weather days in advance?
Hold on. Okay.
One of the key tools they use is the Global Forecast System model. This model, developed by the National Centers for Environmental Prediction, plays a vital role in forecasting weather conditions up to 16 days ahead. It's especially important for those in high-risk professions, like storm chasers, who need accurate data to navigate severe weather. The Global Forecast System model runs for times a day, gathering data from satellites, weather stations, and other sources. This data.
Okay, sorry. I think I show you. This is also another GFS model, but not the one that we are talking about. Nama sama. Okay, so yeah, this is the one I think. GFS. I seem to have lost it. GFS model. Oh yeah, this one. Okay, let me open this one for you. Here we are.
हेलो एवरीवन, मैं हूँ प्रिया और आज का टॉपिक है जीएफएस।
No.
जीएफएस
I
मतलब
think
गूगल फाइल सिस्टम।
yeah,
गूगल
this
फाइल
is the
सिस्टम
one.
को गूगल
Let me check again. Anyway, kalau tak ada dekat sini, I will send you in the link. It was here just now. This is the different one. Okay, let me give you the link later. Not now. Tak boleh. Alright. So sorry about this. I was just browsing through. Before we go to another topic, let's take a few minutes break. Okay. We'll come back in about 10 minutes.